All right, that looks like it's recording. So welcome everyone to this LaTeX seminar. This one I've given a couple of times previously. I think it's pretty handy to have someone who knows what they're talking about with regards to LaTeX, kind of teach you some of the very bare bones basics prior to going forwards. LaTeX is, I think, an invaluable skill that you should have. By the time you hit thesis, you'll have lecturers essentially just asking you to do things in LaTeX, and not having to learn that at that time, I think is a pretty useful thing to do in advance. So I suppose one of the first things we should start off with is, what is LaTeX? Well, LaTeX is this kind of academic typesetting method. It makes it really easy to present data and equations by coding everything from the back end. It's much, much easier to cite references. So rather than having to copy and paste things in from cite this for me, you use a single command that links to a reference list. And one of the key, I suppose, differences between LaTeX and other programs you might be familiar with is it separates the content of the documents from the actual formatting of the documents. So rather than having to drag around images, you essentially tell LaTeX where to put them in advance. And that has a number of advantages. Obviously, this gives you a lot more control over the document. So we say that LaTeX is kind of a back-end method rather than a front-end method like Word. It means that images aren't going to disappear when moved slightly and moved to the 5,000th page. And the reason for that is everything goes exactly where you tell it to be. So you tell where the computer should put those things, and it will do its best to put them there. The other thing that makes LaTeX really, really useful is files can be as big as needed. So if you've ever worked on a long report with some group members, you don't need to worry about it crashing with LaTeX, because it compiles everything rather than tries to render everything in real time. It also makes it quite good in that you can split your documents up into multiple different files and combine them together with a sequence of commands. And the other thing is it looks pretty. So because you don't have to worry about the actual formatting of it, LaTeX handles that and it makes it render it pretty nicely for you. Something I want you guys to keep in mind is every single slide that is in this presentation, I have actually done in LaTeX. So this should give you a really good idea about what LaTeX is actually capable of and how it can achieve everything that you do in Microsoft Office in LaTeX, doing it from the back end. So I suppose the next thing you're kind of asking is, all right, this sounds pretty good. What can I do in LaTeX? Well, in short, you can do everything in Word plus much, much more. So images, they're very easy to put into documents. You want to have images in your documents. This is quite a good one of Elon Musk's mariachi band he hired for a PayPal party. You can also create diagrams from scratch. So this here is a diagram that I made for a research project a little while ago. And I've actually used a program to generate code that LaTeX can interpret to draw this image. So I haven't actually gone through and saved it as a PNG or anything. This is just sitting as code in a document, which is kind of unique. You don't really see that in many other programs. You can put GIFs in LaTeX documents, which is kind of good. Presentations, that's useful, but other documents, maybe not so much. Handy to know you can anyway. And of course, that should be pretty impressive to you. I suppose one of the main reasons that people use LaTeX is its ability to render mathematics. So all your maths sheets that you do at university, all those tutorial sheets are actually rendered using LaTeX. And you can do a range of different things here. Of course, there's inline mathematics that sit in sentences. You can do block mathematics. with integrals and infinity signs and funny symbols. And you can also have automatically numbered equations as well. So rather than trying to work out how to do that in Word, LaTeX will do that for you and automatically number the equations. You can also do some other things like add in special math symbols. So in this case, some bras and kets that we have in physics have been rendered there. You can also render things. I was saying to Sean and Nick before that this is meant to be a sign graph, but because I rendered this on the fly, it's not a sign graph. What it is, however, is a projection of a Klein bottle that the code I've written is a little bit buggy and generated backwards. But the key part of this here is what I've told LaTeX to do is not insert an image. I've actually given it the equation for a Klein bottle, and it has gone through in the back end using some other dependencies and actually generated this image straight from the mathematics. So being able to do that and have it kind of solved within a document is a really unique thing and kind of handy as well. It means that you don't necessarily have to rely on generating things outside of the LaTeX space. Another key thing is LaTeX can be used in things like MATLAB plots and also Python plots as well. So having it so it interprets the axis labels and the titles and uses mathematics there is kind of a cool thing. And what it means is that your documents where you include figures, you don't have a clash between the fonts, between your actual document and the figures you generate, because all those programs actually have a LaTeX interpreter already built into them. So that's kind of nice as well. Makes everything look nice and uniform. Here's an example of that where I've changed the font style for this MATLAB image of the landing of Apollo 11 on the moon. So inserting that into a LaTeX document makes it look kind of nice. Some other cool things you can do is you can actually put objects inside of documents as well. So say, for example, you had a design that you wanted to show off, in this case, the MUGS mug. If you really wanted to, you could insert that into a PDF using LaTeX, which is kind of nice as well, but a little gimmicky. All right, hopefully that has given you a pretty broad overview for what LaTeX actually does and why it's cool and why you should use it. I suppose the next thing you're wondering is how you actually go about learning it. So there's a couple of things here that I want to introduce, one of which is looking at compilers. So LaTeX, as I mentioned, is a compiled language. You write the backend for it. It goes through a compiler. The compiler interprets the commands you've given and generates a document on the other end. So if you have Windows rather, MikTeX is a pretty good local installation. I've used that in the past. Pretty easy to use. It's got good package support from this thing called CTAN. So packages are external libraries that you can import in from the internet. Unfortunately, it's not the prettiest, and you don't have a way to turn it into dark mode. So you probably wouldn't want to be coding documents at, say, 2 a.m. Because it's not too nice on the eyes. But there is another option, Overleaf, which we'll be using today. And this is actually web-based. So it's got cloud storage. It's essentially the Google Docs of LaTeX. It's really easy to use. It has GitHub integration. So the LaTeX documents you write, you can actually push to a repository and you then have version control. Good thing is that all of you guys will have a free Pro Plus account for registering as a UCID student, which is nice. You can have multiple authors on the document as well. The only kind of downside is some of the more niche packages that are quite specialized might not necessarily be recognizable. So something to just be aware of going forward. So as I mentioned, we'll be using Overleaf. I do have in the chat the link to that. If you haven't set up an account, please go forward and do that. And we'll be kicking off with a few basics from there. So just give me a moment to go over and show you what Overleaf looks like. So this here is my Overleaf document. You can see I've written quite a few things here. In order for you to go through and make a new document, you want to click this new project button and hit this blank project. It'll ask you for a project name. So in this case, MUGS LaTeX seminar, and this is going to annoy Overleaf because it's got some underscores in it, but that's all good. And I'm just going to clear everything out of here because I want to talk through a few things about it. So if we go back to the slides here, there's a couple of things you need to kick off a document. The first one is this document class command. So what this does is it tells LaTeX you want to use an article class of document. There's also different classes like book, and some journals have their own classes as well. What we have in the square brackets here is an additional input. So something that we want control over in terms of the defaults that LaTeX has. In this case, we want 12-point font. The next thing you need to do is you need to actually define where the document starts and where the document ends. So, okay, let's go through and type those things in. \document class. Now, a good thing about Overleaf is it has autocomplete enabled. So if you hit tab, it will paste in the comment that's been highlighted there, which is kind of nice. So in this case, we want 12-point font and we want the article class of document. The next thing we need to do is define where the document starts. \begin document, like so. And then you can put some content there. So, hello world, this is my LaTeX document. If I hit Control S on the keyboard, that will save, and it's gone through and generated this sheet of paper that says, hello world, this is my LaTeX document. This \ here is a command. We'll get to those in a few moments time, but LaTeX, of course, has built their logo in as a command. So in doing that, you've just told LaTeX to create a new blank document. Is that it? Well, no, there's a couple more fancy things that we need to do. So some of the things that are really important is what comes before this begin document. So this is what's known as the preamble. You do this to load all the things that the compiler needs to gather before actually rendering what the document is. So this might be defining new commands, loading packages, for example, and we want to start customizing this. So let's go forth and add in some extra fields here. A \title with a title, a \author with your name, a \date, \today. And let's see what it does. Another key thing is we want to have this command \make title in the actual document. So we'll go forth and add those in. \title, hello MUGS, \author, my name, that date, \today. And the next thing we want to do is we want to put in that \make title, like so. Control S to compile. And look what LaTeX has done. It's given us a nice default title. It's put our author at the base of that, and it's put in today's date. So a couple of things I want to go over just really quickly is these are all predefined. It's \title, \author, \date. They're kind of what's in the default article class. This \today command is kind of unique in that it grabs from your computer what the current date is, and then uses that to live render what that date is. So it means that you don't need to go in and actually type the date. It'll just put it in there for you, which is kind of nice. And if you update a document, it'll update the date. So you could have something that goes, date last updated, and it'll automatically handle that for you, which is kind of nice. That \make title command as well just inputs those fields that LaTeX has. The next thing we want to do is we want to start looking at some sections. So this is kind of nice and intuitive. We want to add a section, so we use the section command, my first section. Okay. Save that to compile, and you can see that we've got the number 1 here because it's the first section and a title for that section. If we add some other sections in, so another section, my second section, spell that correctly. LaTeX will go through, compile it. It knows that this is now the second section in the document because there's 2 commands. So it's put a number 2 there, and it's put the title to that as well, which is nice. And it's doing all that automatically. So there's no screwing around with Word to be able to do that. LaTeX is interpreting that based on those commands. Now we've added in some sections, we can actually go through and add in a table of contents. Now, this is something that I know is really finicky to do in Word, and LaTeX does it all in one command, which kind of makes you wonder why on earth, Word doesn't do it. So in this case, we want to add in the table of contents. And you can see that it's added in this content section automatically with my first section, my second section, and it's even generated the page number automatically. This is page 1, and it knows both of those are on page 1. If I move one of these to a new page using a new page command, my second section should go to page 2, which it does. It's on page 2. And my contents automatically update. I haven't needed to go through or do anything. LaTeX knows where I've put them in the document structure, and it's reading all that back to generate, which is real nice. All right, now we get to the important stuff, which is in regards to mathematics. So there's a whole bunch of different commands and different, I suppose, packages to help with this. But in effect, it's really quite easy. In order to put things in line, so in a text structure, like a sentence, you use these $signs. And what that'll do is it will tell LaTeX between these 2 $signs, I want to render this section in math mode. Let's have a look at what that looks like. So I'm going to come down to my second section here. I'm going to write a sentence. I am displaying some inline maths here. Okay, and then I want to add my 2 $signs, do a \tan to put in the tan function, and a \alpha to tell LaTeX I want the special character alpha. Save to compile that, and you can see that LaTeX has now rendered this tan alpha as we would have it as actual written maths. Whereas if we look over in the document structure, I've put in the commands for that. So this is LaTeX handling the formatting for us using these interpreted commands, which is quite nice. You can do other things, so you don't just need to have it in inline format with these $signs. You can also have it in block format. And this is using these square brackets with a \, in front of them. So we can go through and add this. I might copy and paste this command just in the interest of you not having to watch me write it out word for word. So we'll go through here. I can come down and go now want to show some block maths commands. Paste in my command here and recompile this. Okay, so LaTeX has now interpreted that and put in this integral. There's a couple of things I think is worthwhile talking through on this slide. And it's in relation to how you actually go about constructing maths. So I've entered the block math environment with this symbol here. I then want to have an integral as the first thing I have. So it's very similar to how you would actually write maths from left to right. It's the same way as how you write it in LaTeX. So this \int is the integral here. This underscore says I want to put something at the bottom of an integral. And in this case, it's minus infinity. So that's the infinity symbol. At the top of the integral, I want to have the infinity symbol again. So that goes there. I then want to have a fraction. So that's my \frac. At the top of that, which is the first curly brackets here, is this \cos of x. And then at the bottom, x² + 1 dx. Then on the other side, another fraction with a pi on top and e down the bottom. Something that you should be aware of is these curly brackets get used all the time in LaTeX. They are probably one of the most used things that you'll actually put through. So just be aware of that. If it throws you an error, chances are you could be missing one of these curly brackets. So make sure they're always in pairs. The other thing is that maths also comes in what's known as environments. So we had that begin document, end document. That's what's known as the document environment. You can also have environments that sit within that. So in this case, an equation environment. So a little challenge for you. How would you go about generating this function in LaTeX and having it render? I'll let you guys have a think about that very quickly. It's derivative sine x over derivative cos x equals minus cot x. While you're taking 30 seconds to think about that, I'm just going to set up my equation environment like so. I'll give you another 10 seconds to think about that. All right. So the first thing we want to do is we want to have this sine x over this cos x. So that means we want a fraction environment. These sine and that cos are obviously their own commands. That d is just a d, that d is just a d. Those x's are just x, and there should be a cot function as well. So we can go through, do that quite easily. In this case, \frac d of sine of x over d cos of x equals minus cot of x. Render that, and that looks pretty similar. So that's good. So that's, you'll notice as well, that has gone through. If I scroll over a bit, and it's gone and put a number in there. So that number comes from this equation environment as well, just as an FYI. You can also get rid of those numbers. So in this case, using this star command, and this align environment is slightly different. So what this align environment does, it actually makes sure that it aligns certain things in your equation environment. So in this case, some equal signs. So how we would go about doing that is come over here, begin, align, and we want the align star because we don't want it to have that number on the right-hand side. F of S equals, now this L is a curly L, and that's what's known as a math cal, a calligraphic math font. So in order to do that, \mathcal of L, and then to put the curly brackets around it without LaTeX interpreting those as a grouping, we need to put some backslashes in there. We want this equal sign to line up with another one. So the align symbol is this ampersand, and that goes before our equal sign because that's where we want to align to. And then we want to create a new line, which is 2 backslashes. Align the below equal sign with another ampersand as an equals, and the fraction of 1 on S, like so. Recompile that, and we have an error. So I'll talk through that in a second. But that's how we would go about doing that. Now, you'll get errors semi-frequently. Don't freak out about them. Happens pretty regularly. You just come over here and click, and essentially LaTeX is not too sure what's going on with this align star environment. And the reason for that is we need to load a package. So the package that we need to load is this AMS math package, the American Mathematical Society math package. And we need to put that in the preamble. So the preamble, just as a refresher, is before the begin document. So / use package AMS math down there, and recompile. And now all my errors are gone, which is nice. And this now looks very similar to what we had on the previous page. This is quite common sometimes. If you look on Stack Exchange, pull some code, might not work first go, you could be missing a package. This AMS math package, I just load it for all my documents because I know I'll end up using something out of it at some point anyway. So handy to be aware of. So once you've checked that that works, you want to load the graphics package. How do you load a package? Well, you use this / use package command. So I'll give you a couple of seconds to do that. The good thing about Overleaf as well is it will actually look at what packages it can use natively and give you a selection for them. So in this case, typing in graphics gives you 2 options, graphics with an S and graphics with an X. The X has extra stuff. I use them both kind of interchangeably. So the next thing we want to look at is putting in some pictures. Okay. So how do we go about doing that? Well, first off, we need a picture. So I'm going to come over here and get a picture of a Lego man, because why not? This one, Lego man astronaut. Save the picture there, like so. And I want to upload it to LaTeX. So I'm going to come over, grab my downloaded image and upload it. And you can see that now my image is sitting in my Overleaf project, which is nice. So there's my image just sitting there. The next thing we want to do is we want to tell LaTeX how to put a picture in. Okay, so this is using, again, another environment, the figure environment. And there's a couple of things here. So we begin the environment. This here tells LaTeX how we want to align it. So in this case, this H and an exclamation point says to LaTeX, I want you to put this picture here, no matter what. It's a kind of hard alignment. This / include graphics tells LaTeX where to find the graphics and to put it in. We can then add a caption, so might be Fig 1, a Lego man, and add a label. So if we wanted to go in figure 4, LaTeX will do that automatically in the background, which is kind of nice. So all right, let's now go through and add that code in. I'm going to add a new section. Testing graphics. Okay, come down, add a figure environment, begin figure, and you'll notice that Overleaf knows what this environment is, so it's actually already gone through and pre-filled a lot of this stuff, which is kind of nice. So the graphics we want to include is this Lego Man astronaut, and there we go. Click do a tab, and it will automatically put in that file name, though I might change it because it's kind of long. Cool. Come down, get rid of that, and add in Lego Man JPEG. What do I want the caption to be? Lego Man. And I want to add a label as well. So in this case, it's a figure of Lego Man. All right. Recompile that. And you can see that it's not sitting there, but it's sitting down here somewhere. This is a pretty big image, so we actually need to tell LaTeX to reduce its size. So I can do that by adding in this optional set of commands in the square brackets and going width equals, let's say, half the width of a page. So in this case, that's going to be 0.5 for half, \text width. And this text width is a set width for the page. So if you change how wide your margins are, the amount of, oh, it didn't like that for some reason. I suspect you've forgotten. Nice. I don't know why it's doing that. That's all right. We'll add in some alignment too. I might need to get rid of that and set the width manually. Yeah, let's set the width manually to 5 centimeters. And it really didn't like that either, did it? That's embarrassing. All right. I think the reason for that is I need to load the graphic X package. Let's try that now. Width equals 0.5 \. And yeah, it's like that. All right, cool. So I changed graphics with an S to graphics with an X. I said it did extra stuff. One of those things is resizing images. Cool. So as I said, that H apostrophe command, which I added in there, has told LaTeX to put it in exactly underneath that heading, which is kind of nice. So it's done that automatically. I haven't actually needed to drag it around with my mouse or anything. It's doing it on its own. All right, so we've just learned LaTeX essentially to the stage where you can do what Word does, but you can do a whole lot more. So there's thousands of packages for different things in LaTeX. The only way you can really learn them is by going through and using them in documents. So you have to have an idea for what you kind of want to do in LaTeX and go forth and search up on the internet how you go about doing them. And you'll discover a whole range of packages from there. Stack Exchange is going to be one of your biggest helping hands for this. There's a massive community on there that posts solutions to things, which is nice. But the best way of continuing to learn LaTeX is to go about keeping using it. We've only really touched the tip of the iceberg for what LaTeX can do. So some other things that you can have LaTeX do that is really, really quite helpful is you can actually have it solve differential equations. So those vector fields you might have seen in first year maths, LaTeX can actually generate them automatically from an equation in the background if you really wanted it to, which is kind of nice. You can also have it plot natively in documents as well. And I'll give an example of that in a moment. You can also do presentations, though I will say I've done one presentation. That's a lie. I've done 2 presentations using LaTeX. The rest of them I do in PowerPoint because much easier, but you could do all your presentations in LaTeX if you really wanted to, if they were very maths heavy. There's some other programs that I want to introduce you to that I find quite worthwhile in helping to create some nice looking documents. So one of them is TXZ EDT, which I'll bring up. And I may have broken this installation, I don't know. But essentially what this is it will generate some LaTeX code based on what you draw in this area. So if I wanted to draw a rectangle, I can draw a rectangle and it will generate the commands there. At the moment, this installation is broken because I don't use it on Windows, I use it on Linux. But you can add in all sorts of things and do really nice stuff, and it should render on this side. But the good thing is you can copy and paste this code. So in this case, I've copy and pasted the code there. If I come back to my document, I can add in a new figure, so. And in place of this include graphics, I can actually copy and paste in that TXZ picture stuff. If I put that just there, recompile, I might be missing the package, TXZ. I can go through and it's generated 3 ovals and a rectangle, which if you look in here, 3 ellipses and a rectangle. And it's doing that from a set of commands. I haven't manually gone and drawn it. It's generating the commands, which is nice. So it means that your documents are actually a lot smaller in size as well, which is quite cool. So that's one thing I use. NewPlot as well, which does those plots I showed earlier, the Klein bottle. Bit more tricky to use, but worthwhile if you need that sort of thing. The other thing is MATLAB, which I know the first years don't learn anymore, but I'm sure you'll end up coming across it. Changing your labels and figures to so they look like they're from LaTeX makes your output integrate a whole lot nicer in your documents, which is good. There's really good integration for that as well. Image Magic is a command line image editor, and you can do some funky stuff in there as well. There's a few things that I want to point you to, one of which is a template I've made for UCID reports. So that sits over here on GitHub. And essentially all you need to do is download this, upload it to a new project on Overleaf. And what it will look like is, one sec, it will look like this once it compiles. It takes a second. Looks like this. You can add in subject, assignment number, title, subtitle, your own author, ship in there. And it's a pre-formatted report template, which is kind of nice. Makes it all your things look really good and impress tutors, which is always handy. The other thing is something that came across, I think on Twitter a while ago, which is this game called Technique. I wouldn't actually play it for fun, but it's pretty good to work out how you go about actually typing maths and getting aware of what all the different commands are. So in this case, y equals e to the, I won't do this whole thing because that's a very nasty equation. Int e of x d x, or I think it's dd of x. Yeah. Yeah, look, close enough. But yeah, you can go through, type the things out, and essentially teach yourself what all the different symbols are. which is handy for getting started as well. So I recommend that. That's it for this seminar. If you have any questions, please do let me know. As I said, we'll post the recording to this a little later on, so you can go back over it, but all the slides are sitting on that website I pointed to. So the slides just there, and you're welcome to review them in your own time as well. But yeah, thanks very much for coming. Hopefully you learned something, which is good. And yeah, any questions, please let me know.
Hey, Jack, how can we